Hi everyone, I'm John Curley. Lexar Homes has asked me to help you better understand what a high-performance builder is and why this process makes Lexar Homes your best choice. So I'm in the Lexar Design Center, and with me today is an industry expert. There he is right there, ladies and gentlemen, Gord Cook. How are you, Gord?
Good, John.
Listen, I Googled you last night. Here's what I found out about you. You are a thing known as a building scientist. Two words I've never heard actually used in the same sentence before. You've been in the business for 30 years, and when it comes to high efficiency, energy control, and moisture control throughout a house, no one does it better.
Oh, thanks for those kind words.
Well, listen, I'm buttering you up because I'm probably going to ask a whole bunch of really dumb questions while I'm with you here today, and I just want you to take pity on me.
No problem.
All right, here we go. Get ready with the pity. Okay, so I'm looking at this kitchen, and I see beautiful laminate floors. Countertops are gorgeous. They're set in perfectly. The cabinets look great. Everything looks good. So to me, I look at this and I say, well, this is a well-built home.
Absolutely. These are the kinds of things that are very exciting for new home buyers today. The great choice, the great service that you're going to use every day. What we want to chat about today is really about the things that you can't see behind the walls, the kinds of things that make Lexar the high-performance builder that you spoke of earlier. So what we'd like to do today is show you at the Lexar Learning Center the elements that Lexar puts into their house that's made them really have the reputation of one of the finest builders in the country.
Okay, so you're going to show me the science behind the building.
Absolutely, and it's really understanding how the elements work together, what we call house as a system effects, that every choice that you make affects other choices that you make. So let's go over to the Learning Center and have a look.
All right, lead the way. Okay, Gord, where are we now?
We're actually in Lexar's Learning Center, where it gives me a tremendous opportunity to show you their commitment to what we call building science, the understanding of how materials go together, using those tried and true materials, but in a way that ensures proper performance over a long period of time.
So you're going to show me how Lexar includes these building materials in this technique.
Yeah, exactly. And it starts with good selection materials. Then it talks, you can imagine, moving towards really skilled craftsmen. And most exciting to me as a building scientist, Lexar conducts frequent training with their staff and their subcontractors to teach these techniques and ensure that they're done properly.
Yeah, but you'd think all builders do that, right?
Well, that's what you might think. And as I travel the country, see hundreds of builders, there's a lot of builders who are meeting code levels, and codes are great.
Right.
But in today's world, we would say most homeowners expect a little higher performance than the minimum. And this is really about understanding the mix between a good skilled craftsman, making sure that they're trained on a regular basis, and then integrating the best building science techniques to ensure they perform well over time.
Okay, so show me the science.
Yeah, it's a really good start. When we talk building science, we're really first worried about moisture, water. Water's the one thing that destroys buildings and building materials. Do you guys get a little bit of that stuff out here?
We get a lot of rain when it's not raining.
Even when it's not raining, right. And so you can imagine, pretty obvious, the first thing we want to think about is the roof. That's our first line of defense.
Yeah.
And if you look up, you'll notice pretty standard stuff,
there
right?
We go.
Everybody's
Shingles,
isn't everybody doing that?
Yeah.
Absolutely. And asphalt shingles, we want to make good choices there, but they're the first line of defense. Little known that a lot of water actually gets up underneath the shingles. Wind-driven rain, we get some of those avenues, or some of those circumstances. So underneath that, you'll notice that sort of white grayish layer. That's called a synthetic roof underlay. Historically, builders use building paper. Why? Because it was the only thing we had. And building paper isn't necessarily the best. You can imagine paper, when it gets wet, really degrades in a very short period of time. This synthetic underlay lasts much longer and really matches the life of the shingles much better. But then, even more important than that, all the water ends up at the edge of the roof. Notice that black layer, it's called a peel and stick. This is called an ice and water shield, and this is a layer that's totally impenetrable, self-sealing, so any water that ends up at the edge of the roof has an opportunity to dry before it does any damage. And then just even that little piece of metal, notice that little drip edge, that brown piece of metal, that's to make sure any water that does come off the edge of the roof doesn't go down the face of the building, but actually gets kicked away from the building. So you'll notice something as simple as roofs, adding 2 or 3 extra layers adds to the performance of that roof.
This is so depressing, because I know I did not have a high-performance builder. Right. So I'm thinking right now, my roof that I'm supposed to get a 25-year warranty on is done in what?
Well, this is why we hear people say, well, it's supposed to last 25, but I only got 15 out of it. And that's the shame of this, right? Just, you make an investment in a new home, you really would like it to last a long time.
But I stood there and watched them put the roof on, and I'm like, there we go, there you are. And they didn't have any of that stuff.
And they would say, well, it meets code, and it does, but in today's world, we would say, boy, we probably want more than just code. And we have to add factors to it, things like how's it gotten more complicated than ever before, our roof lines have changed. And so our expectations have to go up, for sure.
So my first line of defense is already in trouble.
Exactly. And then we'd say, boy.
I have a feeling, Gord, this is just going to get worse.
Well, no, we're going to be fine.
Okay.
The good news is you've got Lexar, who really understands this stuff. One of the few builders in the country that really understands the science behind how houses work.
Okay.
But let's go to the next slide.
All right, here we
let's
go.
think about, we got the roof, now
Okay.
we got to think about the walls,
All right,
right?
yeah.
And so we make a great choice with a really good siding product, a fiber cement board product that does a really nice job in terms of colors, durability.
Yeah, I got this on my house.
Yeah,
okay,
it's
go
really
ahead.
good stuff.
Yeah, okay.
But and a lot of people think, well, that's got to stop all the water, right?
Yeah.
What we don't understand is there's actually about 1 to 5% of the water that actually gets up in behind. And when water gets in behind, we want it to get out.
Right.
Here's something really simple that Lexar has done. They've partnered with DuPont Tyvek, who makes this. Notice these little crinkles.
Yeah,
in
right,
this?
yeah.
What happens when you put this up tight? Water gets in behind. It still has the ability to drain out. It
Oh,
doesn't
so it's
stay in the
running
wall.
down these channels.
These channels. Isn't that
Okay.
odd? This adds like 2 cents to the per square foot to
Yeah.
the cost of a house, and yet it's so important when you're using these high performance materials in
Yeah.
order to get that. Even more, John, we see this really nice
Yep,
looking, right?
yep,
Adds
yep.
tremendous value, that great look.
Yeah.
But this material absorbs when it rains, holds huge amounts of water, and if we don't have drainage behind it, this stays wet for long periods of time, and inevitably the sun is driving that moisture into the wall. So they've added another layer of protection, not only the drainage layer, but notice this foam layer, which
Right.
these grooves in it, that again ensures very rapid drainage.
Mm-hmm.
All building scientists are saying we need drainage behind walls because our walls are getting wet, they're staying wet for
yeah.
longer periods of time. So we have to have that kind of performance. It's going to be fun.
No, it's not. No, Gord, let me tell you. I watched them put this on because
Right.
they put it on wrong. The first color was wrong. So I stood there and watched. And this was not there.
No. And
This is here.
Right.
This is here. There's something, this is like a felt, black
A
felt.
black felt.
But that's essential.
yes, and so it's really a system of layers, right? The drainage, the synthetic house
Yeah,
wrap
yeah.
that doesn't stay wet, then the drainage layer in front of it, and then all the traditional stucco layers in front of it. But let's go to, not to get you more depressed, but let's think about, let's think about, all of the wall is great, everything works flat,
yeah.
and then we put a bunch of holes in those walls called windows.
Windows, yeah, okay.
And from your experience, do you want more windows in your house or less?
Sure, more windows.
Everybody wants more
Yeah,
windows.
yeah.
It turns out we don't want to be outside, just want to pretend we're outside,
Okay.
right? And so we put in more and bigger windows. Every one of those is a hole. And what is water like? Water likes to come in holes.
Okay.
And the true building science approach, Lexar really understands. Water tends to leak in at the top and does all its damage at the bottom. So we want to make sure the water kicks out at the top. So just a little example of the way it's layered. Notice that house wrap
There it
that
is
we had
again.
over here.
Yeah.
But in fact, in this case, it was cut and this flashing tape was put underneath so that any water coming down the face can't get in behind. So this peel and stick layer really protects the top of this window so water kicks out over the top of this window rather than leaking in behind.
Okay.
That simple little sequencing, we see missed hundreds of times a year. I go out and take pictures all across the country where they want to do good work, right? They're craftsmen. They
Yeah.
want to do good work, but any given day, they kind of forget. And so that constant training, that really it's the commitment that a company like Lexar has to make sure the guys remember that water runs downhill. I always have to be in a shingled and lapped approach.
Okay.
And this really, it's a system of products that are all compatible. We find a lot of builders kind of cutting and pasting using different materials on different days. This is all a warranted system. That is, DuPont will tell you that if you use this system, that they will offer a warranty to a builder like Lexar.
Okay.
And then imagine this. Let's go to the bottom of the window. I said water leaks in at the top,
Right.
but it does all its damage at the bottom.
Yeah.
So here's a really interesting one. There's a piece of tape here. And you go, well, shouldn't that tape be on top of this window flange? That's the window flange.
Yeah, right.
But in fact, if water gets in, we'd like to let it get out.
yeah, right.
So many builders will miss that. They'll put this tape over top of the window flange, and when the water gets in, it can't get out.
I see.
And we'll sew that a little bit later as well. But this idea of making sure we have the proper sequencing, up here the sequencing was this way, down here the sequencing has to be opposite, so water kicks out of that building. And let's go one step further. Look at this little guy here, this little plumbing piece.
Yeah.
So we have all kinds of penetrations in our walls, and in fact, more than we ever used to. Didn't used to have bathroom fans, didn't used to have range hoods, didn't used to have dryers. So now we have these penetrations going through the wall.
Yeah.
And those penetrations go through thermal expansion and contraction. In other words, they move. This little flexible piece, this blue, it's called Quick Flash. Very few builders choose to use it, certainly not required by code. Most builders put a plumbing pipe through, maybe wrap some tape around it, inject some caulking into it. All of those things destroy themselves over time, right? Heat and moisture. Whereas this is a totally flexible piece. I can move that pipe back and forth, and it's a flexible seal so that over time, that water doesn't get into the building.
Because traditionally you see them, they squirt all that foam.
And they squirt foam, and foam's good, right? But foam doesn't stop water, and the foam actually breaks as that pipe moves over time.
I see.
So a simple little device like that, one of those things that we say as a building science, this is literally a few bucks a house to do this. Most builders go, it's not code, why should I do it? Lexar goes, hey, there's maybe 10 of these on a house, let's go ahead and, not necessarily just plumbing pipes, but you think about all the little vents that are going through the wall, the air conditioning line set. Let's just go ahead and do that, get that done. And it really, the trades love it because it helps them be successful. If they're squirting foam, they know it's not going to work and they get discouraged. So this is a way of reinforcing to the trades. We're really committed to building science. Let's get it done right the first time.
Right.
So that handles water, right? So now when we have a building that's dry, we can start to think about the next element, which is heat flow. We'd like to make sure that our walls and our attics are as efficient as possible. So let's go up here.
Okay.
You'll notice the insulation up in the top here, over top of the top plate of the wall. In the old days, we had these really low slope roofs, which meant we couldn't get a lot of insulation. And the outside of the wall, the coldest part, actually stayed cold. And it ended up being a problem. So what Lexar has done is pulled the roof up. They actually do what's called a raised heel truss to get more room. And now you can have a full depth of insulation over top of that top plate.
I see.
This improves the thermal performance of your attic by about 10%. Simply by moving it up a little bit, you can get full insulation underneath. It's called raised heel truss.
Right.
Again, in our experience, less than 5% of the builders in the country are doing that.
Again, you hear that sound? You know what that sound is? That's the sound of my house falling apart.
Well, not falling apart, but it's not the performance you might expect over time, right? That's really what this is
But
about.
Gord, the thing is, I paid a lot of money for that.
Sure.
Right?
And for a few
And I'm paying for it every
more.
month. Every month I'm writing a mortgage check for a house that you're telling me didn't have the science built into it. And slowly the elements are having an effect upon it, and it's destroying the value of the home.
Destroying the value, and you don't get the comfort that you expect. You don't get the performance that, when you think about it, my energy bills, when you think your energy bill isn't something you think about before you buy the house. It's the first month you go, oh my God, I had no idea this was going to be that expensive.
Right.
And it's these kinds of elements.
So
that
the
make the
raised
difference.
truss with that little extra 2x4 in there.
Yes, exactly. Moving that up to get a 12-inch space under there.
It's brilliant.
Yeah, it's very simple.
Yeah.
And here's the next level. If we go to this side. So now we think about improving the performance of our walls overall. Historically, we went from 2x4 to 2x6. What's next? 2x8, 2x10. Walls are going to get thicker and thicker. What we started to realize is we don't necessarily need to add more more wood in our walls. What we really like is a continuous insulation on the outside. So here's a very simple product. It has an R value of R3, which is more efficient actually than the wood stud that it's going over top of. This simple little product, half an inch of foam on the outside, improves the performance of a wall by roughly 25%. The thermal performance of the wall. Very few builders choose to do this. Lexar is offering this, and you can imagine in behind this 50-year siding, 100-year siding, wouldn't it be nice to know that you had insulation improving the performance of that wall by that much? And that's just one of the few examples. Let's go around to the other side and I'll show you a couple more.
Okay, cool. All right, Gord, what do you got now?
Well, so John, we sort of started that conversation about insulation, and often what's lost sight of is what's in behind that wall. And it's really important in insulation to make sure that it's not jammed into the cavity. That's really hard, frankly, for contractors to do, hard for them to be successful with. So Lexar has chosen a different approach. Let's use a material. It's called blown-in batter bibs. One, it gets a much higher R value than typical, about 10-15% higher. But more importantly, it goes in so consistently. Notice there's no gaps, there's no voids, no compressions. With traditional bad insulation, the guys are jamming it in, really hard to make it work right. This really gives the opportunity for a contractor to be successful with it. So much higher R value, very consistent of that insulation value. So you really get the true performance. Notice down here too, that around things like electrical outlets, totally clean, neat and tidy, really no loss of energy. Use that word earlier about wasting energy. Don't want to be wasting energy. The problem if we don't get this done right at the time, this doesn't get worked on until somebody does a major remodel 50 years from now. All those years you'd be wasting heat. So traditional bad insulation, not installed correctly, reduces its R value by 15%. This actually increases the R value by about 10 or 15%. So it's a really nice flip.
Yeah.
And then going a little bit further, we're quite excited as a building scientist to see Lexar taking on another approach called flash and bat. They use a high-density spray foam, which has a couple of important qualities. It is incredibly airtight, and it has some structural to it as well. So when it adheres to the side, it kind of firms up the wall and creates a total air seal inside the wall. No chance of moisture, bugs, anything getting in the wall. And then they would top it up with, so they'll spray 2-3 inches of that and then top it up with traditional bat insulation. Now we're not worried as much about air leakage around the bats because we've got this spray foam.
Well, why not just spray the whole thing and not do this?
Yeah, absolutely. It's totally possible to do, but Lexar is always trying to look for cost effectiveness. So this gets you the performance without a huge amount of cost. So it's a really cost-effective way of improving the performance of the wall from 23 to 25.
I got it.
Plus the air leakage.
So this does the sealing and this does the insulation.
This is an insulator as well. Very high R value actually, but this adds up or tops up that insulation.
I got it.
I wouldn't mind showing you just a few slides of some of the inappropriate choices builders are making in today's world, insulation being one of them.
I like that, inappropriate choices. Okay, sure.
Yeah, John, we had the opportunity to see the techniques that Lexar is using. I thought I'd just take a brief second to show you some of the what we would call inappropriate choices that builders are making out there. It really comes down to the history of housing. You know, tar paper, why did we use it? Well, it turns out it was the only building product we had that met the needs. And in today's world, because of different roof lines, because of the complexity of roofs, this building material is really not the best choice. What we'd really like to be thinking about is a synthetic roof underlay that has a much longer life than, say, a building paper that's going to stay wet for long periods of time. So here's another example. Remember we talked about that Tyvek with the little drainage channels? Turns out there's like 63 different synthetic house wraps that somebody can use on a house. All of them approved by code, but all of them with really different fundamental principles. This is actually a plastic wrap, which it keeps water out, but it doesn't let water vapor. You know, as an in-shape guy, if you're out jogging on a cold winter's day, you wouldn't want the wind getting in, you wouldn't want the rain getting in, but you'd want to let your...
It's called wicking, right?
Wicking or breathability, absolutely.
Right.
So this product doesn't breathe well enough, and specifically in this climate zone, it's not a very good choice. And the difference between this and that wrap is literally pennies a square foot, but Lexar understands the building material science of how building materials work in different climate zones, and a better choice is, in fact, the synthetic house wraps that they use called DuPont Tyvek.
Can I inject code in here again? Does code say this is okay?
This meets code.
Okay, so your builder would say, well, we're meeting code.
We're meeting code.
And then you go, okay, well then fine.
But is it the best choice for the Pacific Northwest is really what that's about, is choosing the best materials for the types of houses that you're building. Similarly, remember we were showing the window before?
Yep.
Can you see what's wrong here? Remember that window flange?
Right, so we have the flange, but the tape should be below it.
Below it.
See?
Should be installed correctly. And you'll also notice it's not a very good adhesion. So we have an inappropriate tape installed incorrectly, and a tape that really doesn't adhere very well anyway. It's a lack of compatibility. And Lexar has been very careful about choosing materials that work well together. The window manufacturer talks to the flashing manufacturer, who talks to the house wrap manufacturer, who talks to the siding manufacturer to make sure they're all compatible materials. Specifically here in the Pacific Northwest, trade contractors are working on days where it's really wet, need to make sure it adheres correctly. And then lastly, remember that little blue quick flash?
Yeah.
You'll notice here, there's those bits of tape and caulking. And this siding product, wonderful siding product, but as this line set or plumbing pipes went through, I really need to make sure that water doesn't get into this wall. And with this particular application, you'll notice, I just don't know how you finish that off. It's not going to look good if I beat it up with beads of caulking, but more importantly, water's going to get inside. And it's not for lack of trying. These are guys trying to do good work, but frankly, they're not given the materials that they can be successful with. Those are the kinds of things that we look at Lexar, those simple little things that just take a few extra minutes, a little bit of design thought, material selection, working with manufacturers, then training. That's really what this is about as we move through. John, here's another example of insulation. Remember we talked earlier about more insulation being better? But actually it's not just about the amount of insulation, but how well it's installed. Insulation gets its insulation qualities by the air spaces within it. And if the insulation is crowded or packed into the wall cavity, it actually ruins the R value. So see little examples here where it's just kind of been spaced and shoved in. And the guy thought he was doing a good job packing that insulation in, but actually in that location, the performance of that insulation is pretty much gone. And the overall impact, we talk about insulation, the overall impact is reduction of about 15% of the performance. Similarly, little job around here, around the electrical outlet, all these little gaps and voids. This really needs to be cut rather than just jammed in. The contractor needs to take the time to actually cut that out. This is the kind of thing that in the Learning Center here that Lexar would share with their insulators and say, our quality assurance program says that you have to cut behind. Here's one a little less obvious on this picture. This you can see is the edge of a tub surround.
Oh, yeah, okay.
Yeah. And so one, we want to insulate in behind it. And we kind of like there to be insulation all the way up.
Yeah, that's
so
right.
we don't want, and here's what's happened in this one. The insulation's actually fallen down in behind the tub. This isn't going to get insulated, at least we fear it's not going to get insulated. Boy, that would be a shame. But even in behind this tub, air and moisture. It's a hot, humid place,
Sure.
and moisture can get in behind. So what we really need in behind here is a material as a moisture seal and an air seal to make sure that there's no air or moisture behind this wall. So insulation takes about an extra hour a house. We call it grade 1. All of the insulation manufacturers have all decided on this grading of insulation, 1 being best, 4 being worst. And they all want and they will train to make sure contractors install the grade 1. Just not all builders choose to understand that and don't really enforce it on their sites. And it's really an extra hour or 2 a house to make sure it's done correctly. And you can imagine the next time this is going to get fixed is
When there's water damage and someone has to get in and repair the entire wall.
exactly. And that could be years and years from now. And what a shame that is.
Right, and every single month when you write the check to the electric company or the heating company, you're wasting the money as it's going out of the wall.
Attaboy, I love that phrase because
Yeah.
the waste of money
That's
is
right.
really a pretty powerful one. Here's another interesting one. You know, look at this piece of wood. This is called a header.
Sure.
The header is designed to carry the load from a roof so that it doesn't impact the windows.
Yeah.
This header is actually a 6x8 piece of material, a 6x8 hunk of tree, right?
Yeah.
Turns out it's not needed at all in this location. Why? Because structurally, this, and it wouldn't be immediately obvious to any homeowner, it's called a gable end. There is no structural load on this particular element. There might be a header needed in another wall, but this wall doesn't need this header at all. So we used a big chunk of wood that, frankly, we didn't need to use, and it ends up being non-insulated. So this entire section of wall has no insulation in it. So we went from an R15 or R24 bat, whatever the builder's using, or R23, and now we get to a place that's not insulated at all. And we use a building material that was expensive, so it cost you more and did less for you. So this is just a little example of, at the Learning Center here, how Lexar is able to train their contractors and have them adhere to the best building science practices. Next, I think it'd be kind of interesting to go out to an actual building site and see what this looks like in the real world.
Great. Well, Gord, this is a beautiful house. I love the ceilings.
Don't you love that?
Yeah.
But you know what? Frankly, as a building scientist, it creates a little bit of challenge for us.
Okay.
So, for example, this wall up here, that's technically an outside wall. And normally people would just stuff some bats of insulation in
So
there.
we're seeing all the silver.
We're all
right?
seeing all the
Okay.
silver.
Okay.
And that's going to just fall out over time. So a company like Lexar understands that and puts actually a foam insulation product on the backside. Now they can put the bats in. It's called 6-sided encapsulation. It stays in place forever.
Okay.
Just one of we're going to talk today and show you on site. There's probably 20 different things we could show you that Lexar is doing differently that we really get excited as building scientists. That sounds a bit geeky, but it's really kind of cool.
Cool. Let me ask you this. So we're in the kitchen, so there's moisture, there's heat, there's humidity and stuff. So this will be important for that?
Well, you can start to imagine warm, moist air rising, cold weather. All of a sudden, that drywall gets moldy. Boy, and you'd go, gee, I wonder what happened up there. Now somebody's got to go fix that up. These are the kinds of things that Lexar is able to avoid.
Okay.
And then we can look at other examples as well. When we talked back at the Learning Center, we talked about water flow and we talked about heat flow. One thing we didn't talk about is airflow. So people always worry about air leakage into houses, noise, dust, bugs. Well, Lexar understands that and actually does a performance test on all their houses to make sure that there's no unwanted air leakage through the wall. Things like the electrical wires around electrical lines. Boy, we can feel little drafts and so on coming through. That costs us energy. Things like underneath the bottom plate. This little foam seal gasket looks so simple. It literally is pennies. But when that's installed, the drywall sucks up to it, and now we have no air leakage.
So I know you're just going to guess on this. My house doesn't have that.
What? No houses have that. It's really kind of interesting. Very few builders take the time or effort to properly air seal a house. Why? Because they never had to do it before. Now the codes are changing everywhere that says we really need to think about air leakage because unwanted air leaks isn't good for anybody. Here's a simple little thing that historically all builders did, and somewhere along the line we forgot. We know that water runs downhill.
Yeah.
If water leaks, you'd like it to run to the outside. Simple little thing, they slope the sill. The way this is framed, they take this piece of wood and slope it. That's called craftsmanship, and it's building science and craftsmanship, and not too many builders are able to get that done. Then in addition, this is foamed, stop air leakage, and then they'll caulk this to make sure that water can't get into that.
So just slanting the wood allows the water to run out and down.
Exactly, and when you think about it, this is the way buildings were built. You go to Italy, you go to Europe, you'll find all their sills are sloped. And somewhere along the line, we forgot to do that, and Lexar is bringing back that old craftsmanship, which really matches the science.
Yeah. Then at this point, you're supposed to say to me, at some point, John, maybe you'll get a high-performance built house.
Well, it would be a good thing, right?
Yeah,
Your next house, you now know.
Lexar.
You're getting educated in the same way that Lexar is trying to educate their clientele.
Yeah.
And now let's show you a couple other things back here.
Okay. We're heading into the master bedroom, right?
Right, yeah, there's a couple of things I wanted to show you here if you're okay. You remember when we were walking in from the street, I pointed out the top of the ceiling, so the attic, that continuous ridge vent.
Yeah.
That's really important. Everybody gets the idea that we need to ventilate our attics to get rid of moisture, to get rid of heat. But here's another little one. We have a continuous ridge vent at the top. But notice each one of these rafter bays, that little baffle that's in place, that creates a 1-inch air gap all the way from the soffits all the way up to the top of the roof line. Many builders just put in 1 or 2. Lexar is doing continuous to make sure the entire attic is ventilated.
So the flow is even.
The flow is even, and you don't get moisture entrapment up in the attic.
Like 90% of this stuff is so simple.
And inexpensive, but it really takes craftsmanship and contractors who kind of know what they're up to, and that's why that training and that commitment to training that Lexar really does is so important.
Yeah.
But here's another type of ventilation that people aren't as aware of. So we like to make our houses as airtight as possible to keep out the noise, the dust, but we also want fresh air in our homes.
Right.
In this particular house, and Lexar does in a lot of houses, they put in a special whole house fresh air system that takes air from outside and distributes it to each room in the house.
Okay.
So this little vent up here,
Right here, yeah.
ensures the proper amount of ventilation. We happen to know when you're sleeping exactly how much air you need to stay happy and healthy and fresh. It's about 15 cubic feet per minute per person.
Okay.
It's about 30 CFM for two
Two people,
people.
sure.
That size to give continuous fresh air of 30 cubic feet per minute. And it comes from a device called a whole house ventilator or heat recovery ventilator. Brings in fresh air from outside, takes stale air from the house and shoots it out. As the two pass by each other through what's called a heat exchange, it pre-warms the incoming air. So you get fresh air without having to pay the energy bill.
Wow.
So this is kind of I get so excited when I see this stuff. It sounds like you're excited
I am too.
But this idea of putting it all together, right?
Yeah.
There's not too many companies that really understand. We like houses to be airtight, but we also would like fresh air in our houses.
Yeah.
Now I want to show you one other thing in this particular room. Notice the water line.
Well, that should be copper.
Typically, right?
Yeah,
Historically,
yeah.
copper. Why? Because that's all we have.
Copper, yeah.
Right. But you can imagine a copper line and an outside wall you might have to worry about.
The freezing
And
cracks
so on.
yeah.
So Lexar has chosen to partner with a company that makes something called PEX pipe, cross-linked polyethylene. And what that means is the pipe is extremely flexible, can actually expand. So there we are in an outside wall. You can start to imagine if there was ever a problem, this would be so flexible that if the house was cold for days and days,
Right.
it's still not going to freeze.
Yeah.
So simple little things like this, that modern materials, the choices that you make inside houses.
And blue for cold.
Yeah, isn't that kind of cool?
And red for hot.
You got it,
How
right?
about that?
Absolutely. Kind of easier to identify,
Yeah.
right? So kind of cool. I got to show you one other room, though.
Okay.
I'm sure you've never seen
I don't know if you
before.
can top the 30
Yeah.
cubic. Yeah, that's pretty cool. Gord, I was asking you about that new house smell, right? The new carpet, the new paint, how exciting that is.
Yeah, exactly. But, as an indoor air quality guy, we
Yeah.
worry about those. Those are what are called volatile organic compounds, VOCs.
Oh, off gas.
Off-gassing,
Yeah.
and frankly, not great stuff, right? So we'd really like to think about ways of limiting those. So one, we try to choose building materials that have low off-gassing. So hardwood floors versus carpets, those are all choices the folks, the consultants at Lexar would help you make from an air quality perspective. Two, we had that ventilation, remember, we had in the master bedroom.
Right.
But here, this is kind of an interesting product. Brand new, I don't know if you've ever seen, this isn't the
Nothing.
finished color of the wall. This
Okay,
is
yeah.
a very special drywall made by a company called Certainteed, and it's called Air Renew. And it has the ability to capture those VOCs They actually seep in the materials. Drywall is actually very good at absorbing those, but in this case, it actually holds on to them and neutralizes them, turns them into what we would call inorganic compounds that are less dangerous to us. So one, we choose materials that don't off-gas. Two, we provide ventilation. But three, this added measure of protection that Lexar's really kind of understood the total indoor air quality and what we want to try to accomplish in-house.
So the wall is breathing, pulling in the bad gases.
Absorbing.
And then neutralizing them.
Right. And hanging on to them. Isn't that kind of cool?
I've got so much I've learned. Is this all going to be on the test?
Yeah, absolutely.
Okay, good.
Let's head back to the showroom and finish up.
Gord, do I look smarter now?
Absolutely.
That's all because of you, because now I know there's more to building a house than granite countertops and beautiful floors and nice-looking cabinets.
That's right, John. Most people don't really know what to look for when they're shopping for a new home. It's the things you can't see that really make the big difference. And so really just keep in mind the single most important thing when you're building a house is choosing the right builder. A builder that will adhere to the principled ethics, making decisions that benefit their customers, while also helping those customers make decisions that deliver healthy, safe, durable, comfortable homes. At the same time, cost-effective.
Gord Cook, you are a wonderful teacher and a great man. Thanks a lot. Appreciate it. Travel safe.
Thank you.
So when you purchase a new home, you expect it to last, and some homes, well, they just can't stand the test of time. Thankfully, Lexar homes can. Confidence is built into every new Lexar home through quality craftsmanship and material. Lexar's best building practices and experience enables them to build energy-efficient, comfortable, healthier, and more durable homes. As a Lexar home buyer, you'll find peace of mind knowing that Lexar stands behind the quality and the workmanship that goes into every home they build. Every new home purchase includes an exclusive, limited, lifetime warranty that is a one-of-a-kind in the industry today. To learn more about how Lexar can build you a home that's built for performance with style and comfort, visit one of their Lexar-trained project consultants at any of their offices or visit them online at lexarhomes.com.